Okay, so hopefully you've had a chance to read through and have a go at exercise 151. What do we know? We know that on a surface of water, 4 square decimeters of that surface area are covered with algae. What we need to find out is how much is covered with algae if the algae population increases by 25%. So hopefully you remember from the first video how to do the percentage increase of 4 or any quantity. So you have your initial quantity and you would do 1 point and then the percentage you want to increase by 1.25, in this case an increase of 25%, times by your original number 4. So of course that would give us 5 square decimeters would be covered with algae if they increase by 25%. 40% is done similarly. A percentage increase of 40% would be 1.40 times 4, which gives us 5.6 square decimeters. And just as an aside, we've always been working here with percentage increase. If we had a decrease of, let's use 40% again, would be equivalent to doing 0.6 multiplied by 4. So a decrease of 40% would be then 2.4 square decimeters. And you notice that actually this is an increase of 1.6 and that's a decrease of 1.6, which we should expect because it's 40% of the same quantity. So a decrease of a percentage just means that you take 1 and you take away that decimal that this equates to from 1. So back to increase, an increase of 75% will be 1.75 times by our 4, which would be 7 square decimeters. And then D asks us for then a percentage increase of P. Now I can't just put 1 point P because obviously that doesn't really work in terms of algebra. So I need to go for P over 100 times by 4 plus, so that's P% of 4, plus my original quantity of 4. And of course here I can take out the 4 as a factor, and I can have P over 100 plus 1. So I've taken the 4 out of this quantity to get this one here, and I've taken the 4 out of here to get our 1. And I can bring these over the same common denominator, so that's P plus 100 over 100, which equates to 4P plus 100 over 100. You might have your solution in a different form. We can also cancel the 4 and the 100 to be 1 over 25 to get P plus 100 over 25. That also works as well. And you can check this. If you then put 25, 40 and 75 into this formula, you should get the same results as we got for A, B and C. And actually, it even works for our percentage decrease if P were then a negative number. If a decrease of 40% meant that P was minus 40, for example, that's something that you can check as well. Then finally, E shows us the beauty of doing percentages multiplicatively, like we've been doing it this time. So we've got the algae increases by 25% on the first day, 20% on the second day, and 15% on the third day. So we have our original amount, which is 4, and that amount increases by 25% on the first day, Then we have this new amount on the first day. Then this amount increases by 20% on the second day. And that's what we have then on the second day. And then this amount increases by 15% on the third day. Which of course, because multiplication is commutative, it doesn't matter which way round that we do it. I can write this as 4 times 1.25 times 1.20, or 1.2, times 1.15. And at the end then, when I put that into my calculator, I get 6.9 square decimeters. And so it's important to notice that you can't just add these three percentages together of having 45, 55, an increase of 60%, because if I were to do an increase of 60%, I'd get only 6.4. You can't think of percentages in this additive way. You have to think of it as it's increased by that amount, and then that new amount increases, and then the new amount increases again. So we get 6.9 square decimeters at the end. So hopefully this one's also clear. Let's move on to our next question. I've got two more questions to do within this video. So on page 53, first of all, I'd like to have a look at question 162. So I assume you've paused the video and had a look at 162. It's about the volume of a sphere and we of course know from page 48 we have the formula for the volume of a sphere, which is V is equal to 4r cubed pi divided by 3. And this is looking at, first of all, if r is twice the length, how does the volume of the sphere change? Well, if r is twice the length, then we could say that it's equal to 2 times the original length, r. So we can put this in, instead of our r, into this formula. So V is equal to 4 times 2r cubed pi over 3, which is 4 times 2 cubed is 2 times 2 times 2, which is 8 r cubed pi over 3. And of course I can do 4 times 8 to get 32 r cubed pi over 3. So if r is doubled, then the volume of the cube is actually 8 times bigger. So we can write this then in a sentence, and I'll do it in text so that it's neater. If we double the length of the radius, the volume increases 8-fold. 8-fold means by 8 times. Then B says, what happens if we halve r? So this time, instead of working with 2r, we're working with r over 2. So V is equal to 4 r over 2 cubed pi over 3, which is 4 times r cubed over 8 times pi. And rather than having this double fraction like this, I can put this in brackets and say this should be all divided by 3. So that gives me then, I can cancel this 4, 1 with this 8, 2. So I have r cubed pi over 2 divided by 3, which is the same as saying r cubed pi over 2 times by 1 over 3, which is then r cubed pi over 6. So, actually, it decreases 8-fold, because we're dividing by an 8 here, and if we were to divide this expression by an 8, we'd come out with this expression. So if we halve the length of the radius, then the volume decreases by a factor of 8. It gets 8 times smaller. So our final question that I'd like to do is also on page 53. And it's question 166. Pause the video, take a look, see if you can do it yourself. So I've paused my recording and I've created a little sketch of the sketch that's provided in the book under page 166. And we need to find out the area of this shape that I've put in blue here. The perimeter of it is in blue here. In English, this shape is an octagon. Because it has 8 sides, it's a little bit, it could remind you of the word octopus, you know, the animal that has 8 legs. That's a nice way maybe of remembering that this shape is a regular octagon. So first of all, we need to find this area by the addition of the different elements. So we have squares. We have 1, 2, 3, 4, 5 squares that are all the same, and then 4 triangles. So let's call the squares big S and the triangles big T. So the overall area is going to be 5 times S, the area of each of the squares, plus 4 times T, the area of each of the triangles. So S is quite easy to figure out. Because they're squares and they have side length A, we can have 5 times A, or 5A squared. The triangles are a little bit trickier. Hopefully you remember the formula for calculating the area of a triangle. Half the base times the height. So if we call this the base of the triangle, half of that is going to be A over 2. And this is going to be the height of the triangle, which of course again is going to be A. So I can cancel the 4 with the 2. So I get 1 here and 2 here. So I get 5A squared plus 2A squared, which I can simplify to be 7A squared. The second part of the question asks us to figure out the same area by subtraction. So if I figure out this for the whole square and then take off the tiny parts of the corners, then hopefully I'll come out to this same answer of 7A squared. So the big square, let's call the big square B for big, is going to be B minus, and again, because of symmetry, we'll call these T, because these triangles here are going to have exactly the same area as these triangles here, because they're each half of one of the squares. So that's going to be B minus 4T. Now B is 3A times 3A, minus then our 4T that we had here, so minus 2A squared. So that's going to be 9A squared, take 2A squared, which is 7A squared. And I hope you get a big feeling of satisfaction for realizing that these two are the same. It's like when you've been clearing your room and it's suddenly then really tidy and everything's where it should be. It's that feeling of, yep, I've done it, it works, and therefore I must be correct. Hopefully you're enjoying that feeling of satisfaction now, and maybe even more so if you manage to do the whole question by yourself. I'll see you next week in class.